Hello, statistics. Here's the second part of chapter 3. Just to let you know, the Screen-O-Matic, which I'm using, limits my videos to 15 minutes, which is why sometimes they might cut off and I have to start a new one. So this one here is talking about if your score in your next statistics test is converted to z-scores. What a z-score is it converts your value into a standardized value based on your standard deviation. So what's going to happen is we're going to use something called a normal table. And when they make comments about something being within 30%, what's going to happen? So what's going to happen is if you have a normal distribution, which remember is your bell-shaped curve, you're going to have your mean right in the middle. Your z-score will be a 0 because your mean is 0 away from your mean. And you're doing it based on your standard deviation. So the way you calculate a z-score is going to be your value minus your mean, and that's going to be divided by the standard deviation. That tells you how many standard deviations away you are. If you think about your normal curve, what's going to happen is your z-scores are like a number line. -2 is going to be towards the left. -1 is next to that to the right. 0 is going to be right at the top of your curve. 1 is going to be 1 standard deviation to the right of your mean, and 2 is going to be 2 standard deviations to the right of your mean. So if your score in your next statistic test is converted to a z-score, which would you prefer? Would you rather be below the mean by 2 standard deviations, 1 standard deviation below the mean, at the mean, 1 standard deviation above the mean, or 2 standard deviations above the mean? Well, you would want to be 2 standard deviations above the mean, +2, because that means that you have one of the higher scores on that test. So this one's going to ask you to calculate a z-score. With a height of 67 inches, Ronald was the shortest president of a particular club in the past century. The club presidents of the past century have a mean height of 73.8 inches and a standard deviation of 2.8 inches. This is where, remember we were talking about variance? If you had a variance, it would be something inches squared, which you can't do anything with. What is the positive difference between Ronald's height and the mean? So what you have to do here is need to open, you could do Excel, you could use a calculator, either one works. So we know that Ronald is 67 inches and the mean is 73.8 inches. Remember, they want to know what the positive difference is. So it's going to be the difference between the two. I'm going to do the value minus the mean because that's the numerator. But the absolute value of the positive of that is going to be a positive 6.8. The difference is blank standard deviations. So they tell me that it's 2.8 standard deviations. So I need to divide that 6.8 divided by 2.8. And notice it says to round to 2 decimal places. The reason for that is your standard normal table is going to have 2 decimal places. So I have 2.428. Next to that second decimal is an 8, which means that 2 is going to become a 3, 2.43. And the reason for that, they want the absolute value on this one. So that's why it's a positive 2.43. However, the z-score, as you can see, is a negative 2.43. And this is going to be considered unusual. And it even tells you here, unusual heights convert to scores between -2 and a +2. So if it's, so a negative 2.43 is less than a -2. Therefore, this would be considered unusual. If it was a negative 1.43, that would be considered usual. So this question is asking about IQ scores measured with a test design so the mean is 102 and a standard deviation is 19. Consider the group IQ scores that are unusual. What is the z-scores that separate the IQ scores that are usual? So lower z-score boundary is going to be a -2. Higher z-score boundary is going to be a +2. Remember, anything lower than -2, 2 standard deviations below, so in -2z, or +2, 2 standard deviations above, higher than that would be considered unusual. The way I'm going to calculate this, I need my mean, which is 102, and then I'm also going to need that standard deviation, which is a 19. I need to do my mean minus 2 times that standard deviation. And that's going to give me a 64 for the lower bound. For the higher bound, I need to do my mean, which is 102, plus 2 times my standard deviation, 19. Upper bound is going to be 140. Some people just subtract 19 2 times. 102 minus 19 is still going to get you that 64. So a question like this, one of the tallest living men have a height of 250. One of the tallest living women is 240 centimeters. Heights of men have a mean of 176 centimeters and a standard deviation of 7 centimeters. Heights of women have a mean of 167 centimeters and a standard deviation of 4 centimeters. Relative to the population of the same gender, who is taller? I need to calculate 2 z-scores here, one for the men and one for the women. And so my man, the tallest is 250. The mean for the men is 176, and the standard deviation is going to be a 7. The value for the highest for a woman is 240. My mean is going to be 167, and the standard deviation is going to be 4. So remember how I calculate this. So I'm going to get a little fancier with my formulas here, but it's going to be my value minus my mean. That's going to be in parentheses in the numerator divided by my standard deviation, which is 7. So my z-score for that guy, he's 10.57 above the mean. For my female, I am going to do my 240 minus 167 in the numerator divided by 4. That got me 18.25. So the woman is relatively taller because the z-score for her height is greater than the z-score for the man's height. Because the tallest man is 10.6 standard deviations above the mean, the tallest woman is 18.25 standard deviations above the mean. So below are 36 sorted ages of acting award winners. Find P sub 20, so the 20th percentile, using the method presented in the textbook. So here's one. You notice I have my box here, open in StatsCh3. Takes a second. I'm going to do the same thing, summary stats columns. Select my variable 1. We're going to skip these pieces. You can just click N so you don't have too many things going on there. And then percentiles. So see how this percentiles? We want P sub 20. That means I need to put 20 in here. Compute P sub 20. The 20th percentile is 28. 28 is my 20th percentile. So here's another one that StatsCh3 is going to be really helpful. Find the 3rd quartile, Q sub 3 of the list of 24 sorted values. So what's going to happen here is your percentiles in the last one can be any percentile. Quartiles, think about quarters. First quartile, Q1, is going to be 25% of the data. Q2 is 50% of the data. Q3 is going to be 75% of the data. I'm going to click on this, open StatsCh3. Again, we're going to do a summary stats columns. Select your variable 1, and in here I have a Q3. Compute, my Q3 is 57. 57 is the correct answer for this one. So this one's going to look for a box plot. So the way a box plot is going to have it, we're going to have a minimum value, a maximum value, a Q1, Q2, and Q3. So our 5-number summary plot is going to be our minimum, Q1, Q2, Q3, and then our maximum. Open in StatsCh3 again. It's going to be the same thing, summary stats column, variable 1. Here, I need a minimum, I need a maximum. I'm going to use that control key to get multiple things. And I don't have a Q2. However, what is 50% into our data? Halfway through our data is our median. Just make sure that as you do these, you put them incorrectly in order. So my minimum is going to be my 4, which is the first number. My Q1 has to come next, which is 11. My median, 18.5, is my Q2 in the middle there. Q3 is 36, and the maximum is 60. What's going to happen is once you get those values, what's going to happen is that 4 needs to be that first line. So it could be either one of these. Actually, it could be any of them. 60 needs to be my last line. This last line's not at 60. He is, though. He is at 60 and he is at 60. Any of these are possible. That first big line here has to be at 11, which they all tend to be. And then 18.5 has to be this middle line here. So this guy is definitely out. That guy's looking good, and that guy's looking good. But remember, but he was out because he wasn't at 60, so now we're down to these two. 36 has to be this last line, though. He's nowhere close to 36. B is my answer. So there's a few more questions. A data value is going to be considered unusual if the z-score is less than -2 or greater than a +2. Whenever a data value is less than the mean, corresponding z-score is negative. So less than the mean, the z-score is going to be a negative, because remember, it's like a number line. Modified box plots, data value is going to be an outlier. And so the formula for that is going to be your Q1, your first quartile, minus 1.5 times the IQR. The IQR is the Q3 minus the Q1, the third quartile minus the first quartile. That's that middle box that you saw on that box plot. And the upper bound for an outlier is going to be Q3 plus 1.5 times the IQR. And which of the following is not a value in the 5-number summary plot? It's going to be the mean, because remember, we have the minimums there, the median is Q2, and we have a Q1. The mean is not in there. Good luck on this assignment, and we'll talk to you soon.